Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Natasha binti Suhaimi. So today I would like to announce that my team's member and I are assigned to the source of new elastomer for our company product manufacturing, which is NBR. So next. So here's a little bit information about my team's member and their roles and the introduction and the background of our company. So in our department of R&D engineer, you have me, Natasha. I was assigned to develop the new rubber, and then Hosnina, she was assigned to improve the characteristic of rubber, and Izzah to find the suitable formulation, and then Munirah to find the suitable price based on the properties. Okay, next, I would like to tell you and show you the logos of the Berjaya Engineering Company, which is our company. And then I would like to tell you about our company background. So Berjaya Engineering Company was established in 2008 as a firm that produces rubber and elastomer products. So the company that has embraced the challenge to explore and develop a variety of manufacturing methods. Our goal is to maximize our ability to provide quality product and services that meet or exceeds our customer requirement, and the mission is to create and maintain total quality company by maintaining continuous improvement of our people, process, product, service, and profitability. We have developed a work environment where employees are respected and feel strong bond, sense of contributing values and the purpose. After long time operations, our company wants to identify a source of new elastomer, which is nitrobutadiene rubber NBR. Therefore, as an R&D engineer, we require authorization to locate new source of NBR product, which is why we choose this elastomer based on provide proposal for this new elastomer product. So next, I would like to tell you about the structure of NBR and the trade names. So as you can see, this is the chemical structure of NBR. And NBR, nitrile butadiene rubber, in short nitrile rubber, is also known under the trade name nitrile, perbunan, and bunan. It is an elastomer, a synthetic polymer obtained by the copolymerization of acrylonitrile and 1,3-butadiene. It is a random copolymer that is the order of the acrylonitrile and butadiene groups, and the polymer change is unordered.
We also discuss about vulcanized property and the classification of the specific elastomer, which is NBR, nitrile butadiene rubber. First, the vulcanized property is a good oil resistant. When the higher amount of SEN in the elastomer, the better oil resistant. Next, vulcanized property also give a good low temperature. This latter attribute of NBR also varies with SEN content. The lower the percentage of SEN in the polymer, the better low temperature flexibility and the poorer oil resistant. For example, the compound which has a nitrorogam elastomer in it, which a medium 33% SEN content, will have a good oil resistant and low temperature down to the region of -40 degrees Celsius. Then, have a good mechanical vulcanized property, which NBR need reinforced filler. Lastly, have a good heat aging resistance is in a region 107 degrees Celsius for continuous use. Special compounding ingredient can be added to increase heat aging resistance. Next, the properties of this rubber compound are determined by its SEN content, which is broken down into 3 classifications. First, high nitrile higher than 45% SEN content. Second, medium nitrile, the range between 30 until 45% SEN. And the last, low nitrile, less than 30% SCN content. In the conclusion, the higher the SCN content, the better is resistant to hydrocarbon oil. The lower the SCN content, the good flexibility in low temperature application. Medium nitrile is, therefore, most widely specified due to its a good overall balance in most applications. Typically, nitrile can be compounded to work over a temperature range of -35 degrees Celsius to 120 degrees Celsius and superior to most elastomer in regard to compression set, tear, and abrasion resistant.
Hi everyone, my name is Nururiza. I will share about rubber formulation and vulcanization system. After a lot of research, my member and I found the suitable rubber formulation and suitable vulcanization system for elastomer MBR. As you can see in the slide, our formulation containing of MBR as elastomer, polyamide, zinc oxide and stearic acid as activator, the MQ as antioxidant, and we use two accelerator, MBTS as primary accelerator, and chemical group in thiazole. So it function is semi-ultra-fast. And for the MTD, secondary accelerator from chemical group curum, and it's ultra-fast. So for sulfur, it's vulcanization agent, carbon black as filler, and castor oil plasticizer. So for this formulation, we can see, we know that vulcanization system, we use semi-efficient vulcanization, semi-AV, because accelerator is 2.0 pHr and sulfur 1.5 pHr. So semi-efficient vulcanization system in approximately equal amount of monosulfidic and polysulfidic change in the rubber network are present, and the system is compromised between a good resistance to thermal aging together with a good fatigue life performance. So that's all for me. So I will pass to my next member for application. Thank you.
Hi, my name is Mira and I will present about the application and pricing of MBR. Natural rubber is more resistant than natural rubber to oils and acid with superior strength but does have less flexibility. In application, it is used in the automotive and aeronautical industry to make fuel and oil handling hoses, seals, bromettes, and self-sealing fuel tanks, since ordinary rubber cannot be used. MBR ability to withstand a range of temperature from -40 to 108 degrees Celsius make it an ideal material for aeronautical application. Second, it is used in safety glove because natural have a good toughness and hypoallergenic qualities. Natural gloves are therefore more puncture resistant than natural rubber gloves, especially if the latter are degraded by exposure to chemicals or ozone. Natural rubber is also less likely to cause an allergic reaction than natural rubber. Natural glove can range from heavy-duty glove in nuclear application to thinner disposable glove seen in medical, laboratory, and cleaning, and also the examination application. Third, MBR is used in textiles to waterproof fabric and improve the quality. The natural rubber has excellent resistance to petroleum products, fuels, aliphatic solvent, animal and vegetable oils, and also fats when it is combined in cotton fabrics. Fourth, MBR can be found in footwear, floor mat, sponge, and a host of modern goods. For pricing of NBR, the global NBR market was valued at USD 992 million in 2017 and is anticipated to grow by 7% CAGR to USD 1,393 million by 2022. During the projected period, the demand for NBR is expected to be driven primarily by rising medical and automotive and also the transportation demand. In the upcoming years, the demand for NBR is expected to be driven by rising demand for NBR growth in the construction and medical industry. That's all from our group about our product, which is nitrate butadiene rubber. Thank you.